Numbers, predictions, results. It all looks great until you ask, how good is my model really? That's where evaluation metrics come in. Welcome to day 26 of the 30 Days of Machine Learning series. If you're just joining, don't worry. You can click right here to access the full playlist and catch up on every step of the journey so far. And hey, make sure to hit that subscribe button so the next video in this series drives straight into your feed. In this video, we're breaking down key metrics like mean squared error, MSE, root mean squared error, RMSE, mean absolute error, MAE, and R2 score, so you can confidently analyze your regression models and make data-driven improvements. First things first, let's bring in the heavyweights. Pandas for data handling, NumPy for calculations, Matplotlib and Seaborn to make our visuals pop. Let's load our dataset and take a quick peek. df.head gives us the first few rows, and df.shape tells us its size, rows and columns. Time to check for missing values, because hidden gaps can ruin our model. Also, dropping the ID column since it's just an identifier, not useful. Dealing with missing values. For categorical columns, we replace nulls with none to maintain consistency. For numerical ones, we use the median, preventing extreme values from skewing our data while keeping the dataset reliable for analysis and model training. Time to convert categorical data into numbers. Using Label Encoder, we assign unique numerical values to each category. This helps machine learning models understand the data better. We also store the encoders in case we need to decode values later, keeping things organized. Splitting the dataset. Y holds the target variable, while X contains features. We reserve 20% of the data for testing, ensuring our model is evaluated fairly. Setting random state equals 42 keeps results consistent, making debugging and comparisons easier. Now training begins. Time to scale our features. Standard Scaler standardizes data by centering it around 0 with unit variance. We fit it on X-train and transform both training and test sets, ensuring our model isn't biased by different feature scales. This boosts performance and stability. Let's visualize the sale price distribution. A histogram with KDE helps us see patterns, skewness, or outliers. This step is crucial for understanding how our target variable behaves before modeling. Let's uncover relationships between features. A correlation heat map shows which variables move together. High correlations might indicate multicollinearity, affecting model performance. The cool-warm color map makes patterns stand out clearly. Bringing in powerful regression models, linear regression and ridge for simplicity, while random forest and gradient boosting add non-linearity and robustness. Each model has its strengths. We'll see which performs best. Time to compare models. We've got linear regression for simplicity, ridge regression to handle multicollinearity, random forest for nonlinear patterns, and gradient boosting for powerful iterative learning. Each model brings something unique. Let's see which one predicts sale price the best. Bringing in evaluation metrics. MAE, MSE, RMSE, R-squared, MAPE, median absolute error, explained variance, and max error. Each gives a different perspective on model performance. Understanding these helps in choosing the best model for accurate sale price predictions. Now let's train and evaluate all models. We loop through each one, train on X-train, predict on X test, and compute key metrics. MAE, MSE, RMSE reveal error magnitudes. R squared shows how well predictions fit. MAPE measures percentage error, and MAE gives robust error analysis. Explained variance tells us how much variation is captured, while max error highlights the worst-case prediction. After running this, we'll have a clear picture of which model performs best for predicting sale price accurately. That's a wrap. We evaluated models, but feature scaling can make a huge difference. Up next, standardization, normalization, and more. Click on the screen to continue.